With just one line of code, this scene manager handles transitions, loading, and data transfer between levels. Should we take a look? Before we get into any code, let's take a look at what this one line can do. So I've got this sample project made with assets from Kenny, by the way. Thank you, Kenny, much appreciated. Anyhow, what we've got here is a simple Zelda-like dungeon game. So that first transition is what you're seeing managed with this line of code. Then we've also got this Zelda-style sliding transition, and then also this sort of fading transition to simulate, maybe changing levels or going somewhere darker. So how do we do all that with one line of code? We're going to be creating this scene manager singleton, or auto load as they're called in Godot, that will allow us to pass the path to an asset that we want to load and define the type of transition that we want to use. Now, of course, yes, I did say one line of code. Obviously, there's a lot more going on here inside the scene manager and in the loading screen that's going to handle the transitions, but I wasn't trying to deceive you. The point I was trying to make is because throughout the life cycle of a game, we're going to be transitioning between menus and the game and different levels within the game and passing data around, I wanted to build a very simple system for doing that because we're going to do it a lot. And I don't want the calls to be complex. I'd like to just be able to say, scene manager, I need this, go get it for me. So here's the basic structure that we're going to be working with. We're going to pass that resource and the type of transition we want to the scene manager. Then the scene manager is going to instantiate our loading screen. It'll play the first half of the transition that we selected. Then once it's at the midpoint where the screen is obscured, it's going to load the new content behind that. It'll then continue playing the second half of that transition, revealing what we've now added. And before freeing the previous scene, if we're moving between two levels, we're going to hand off some data from the old level so that we can initialize things properly. So let's take a look at how each level is constructed. If I click on the root node here, you'll see that the level script requires that we define a player and then create an array of all the doors in that level. So with that understanding of how the levels are constructed, let's take a look at the door. So the door is very basic. It's just an area 2D that's one grid size big with a collision shape on it and this door script. And the door script is extremely basic. First, we're going to make sure that we're only reacting to the player colliding with this. If something does collide with this that's not a player, it's just going to dump out on line 13. Once the player does come in here, we're going to emit a signal and pass along the door itself because the door contains a bunch of information that the next level is going to need. And after that, we're going to look at the transition types, which is one of the enums we'll talk about in a second. If it's the Zelda level transition, we're going to use this load function of the scene manager. And if it's anything else, we're going to use this generic load scene. And then we're going to call queueFree to remove the door because we've collided with it. And this is one of a couple of ways we're going to make sure that we only collide with it once. Down here, I'm not going to go into too much detail, but these are two very basic helper functions. This top one calculates the position in front of the door that we want to put the player when it enters a new level. This other one just inverts up to down, left to right, based on our entry direction so that we can make sure that the player is facing the right direction when they enter a new room. So if I click on the door, we can look at these. We can actually look at these 5 export variables. This first one defines the direction of the room relative to the door. So for example, if I go back to the level, this door here has an entry direction of east, which is this way. So we define our entry direction. We choose which transition we want to use here, how far we want to move the player off of this space when they're entering a room. 16 works for all of the doors, but in the event we have a funky size door or a funky size entryway, you can change that on a per door basis. This is the path to the scene that we want to load, and this is the name of the door that we're entering. So if I'm moving from this door to go west into level 2, I'm going to come through this east door here. So I'm defining west door is arriving at east door from level 2. So basically what happens is when the player collides with this door, it triggers this on body entered, fires off this player entered door, which the level script is listening for, and it tells the scene manager what to load and what transition to use, and everything sort of goes from there. So let's move over to the loading screen. I'm going to try to do this somewhat chronologically. The loading screen is fairly simple. It's a canvas layer that has a panel we're going to animate for the transitions. It has a progress bar that we're going to optionally show depending on how long it's taking to load the scene. In our case, it'll probably almost never be shown. We've got an animation player node to handle the transitions, and then I've added a timer that we're going to use to show the progress bar if enough time has elapsed and the content still isn't loaded. So let's just take a look at how this works. I'm going to start with the fade 2. So the way I've set this up is the first half of the transition is a something 2, and then the second half of that transition is the same thing but from instead of 2, and that'll make sense in a second. So our fade 2 just is a basic transition from transparent to black. Once it's black, we start loading the content in the background. When we've determined that content is then loaded, we switch over to our fade from and reveal the new content behind it. So that's basically how that works. We have a fade to black, and then we've got this wipe transition that you saw when we left the menu. And then if there's time at the end of this, we'll add one more together because it's actually very easy to add additional transitions to the system. Looking at the code here, we start by hiding the progress bar because we're only going to show that after we've hit a threshold. I've got it set to 3 seconds. You'll have to choose what works for your project. If the content loads in less than 3 seconds, you'll never see the progress bar, which is totally fine. Otherwise, it just sort of flashes on screen and looks kind of crappy. So I prefer to hide the progress bar until we know we're going to be loading for quite a while. So the scene manager is going to handle adding our loading screen to the tree, which actually you can see if I play this and you look at our remote tree, once I hit enter, you'll see the loading screen appear, and then it gets freed once the transition is complete and the loading is complete. This start transition is called by our scene manager. We're going to check to make sure that the animation we're using actually exists. If it doesn't, we're going to push out a warning, and then we're going to set it to one that we know does exist. This allows us to be warned in our development environment, but if for some reason we ship with an error, the game isn't going to crash. It's just going to use maybe the wrong animation, which is far better than the game locking up on us. We're going to store our starting animation name because we're going to need this when it's time to initialize the second half, the fade from half. And then we start that transition, and we also start our timer. And then you can see down here, this is called by the scene manager after we've finished loading the content behind the middle point of the transition. We're going to stop the timer because if we've gotten here before the one-shot timer has gone off, then we don't want it to go off while we're finishing our transition. We're now using the replace string function to go from fade to black to fade from black. And then we're basically just repeating that same process with the same checks to fade from black instead of to black. And then down here, we're going to use the await command, which will listen for our animation player to emit the animation finished, which every animation by default emits when it reaches the end of its timeline. And then we're going to call queue free to let go of our loading screen. And down here, we just have two very basic functions. One is called when our, shut up, bird. There's a bird squawking outside. I'm going to try to ignore it. Anyway, nope. I am now done shouting at the crow in the tree like an old man. It's a wild ride, folks. Okay, so where was I? This is the function that's called when our timer emits its timeout signal, and it'll just show our progress bar. And then this report midpoint function just emits a signal. Here, I'll show you. We're actually using this in the animation player. So if I come into our two animations, you can see we're animating these properties here. That's these little diamonds, but down here we've got this function track. And when it reaches 0.4 seconds on our timeline, we're actually calling this report midpoint function. This is the signal that the scene manager is listening for to know that we've obscured the whole screen with the transition and that we're going to start loading the content behind it. Okay, so chronologically, we've gone over the doors and how that can trigger the scene manager to call up the loading screen. Now we can take a look at the actual level. Level's pretty simple. Our onReady function disables input on the player just to make sure that we don't move while we're still in transition. This determines whether we're coming from another level. So anytime our data object, which is this level data handoff, I'll show you this in a second, but if our data is null, meaning we didn't get handed that packet from a previous scene, then we're not transitioning between levels, and we can just go directly into this enter level method, which performs a similar check. So if it's not null, that means we are transitioning from a previous level, so we should initialize the player location to be in front of the door that we came through. And then, of course, once we've put the player where they need to be, we're going to show them, we're going to enable input, and then we're going to call connected doors. I'll jump down here. I have actually two functions that connect to all of the doors in our door array and listens for whether a player has walked into it. And again, you're going to see this running theme. Before we try to connect to it, we're making sure we're not already connected to it. And before we disconnect from it, we're going to make sure that we are connected to it. And then we can call these functions when we start the room and when we enter the room to make sure that we're not leaving any signals connected to objects that don't exist anymore. I think Godot does a pretty good job of handling that with garbage cleanup, but I prefer not to leave loose ends. Anyhow, so that's your enter level. This is called by the scene manager once our transition is complete. This is our helper function that we called here. And basically it just looks at the door data that we passed in, pushes them into the appropriate location, and makes them face the appropriate way. So if I play the game, you can see I'm facing left because I'm walking left, and I end up getting pushed 16 pixels into the room, and I am facing left. If that method weren't there to orient the player, when it initializes and reveals this player, he would be in the correct location, but he would be facing to the right, which it's not the end of the world, but it's a little detail that can take your players out of the immersion of your game. All right, so back to the level. So this is the last bit of the level, at least for our sample project, which doesn't do very much. In our door, we emit this player entered door signal. And back in the level, we're listening for that. And this is where we call that disconnect from doors to make sure that we don't fire any more of those. We're going to disable and remove the player. Then we're going to set up our data object. So this level data handoff I'm going to show you, it's just a very basic, it just holds the name of the door that we're coming in through and the direction that we were moving. If I go back to the level, you can see we're creating an instance of that data. We're adding those 2 bits of information, and then we're pausing a process that we're not even using, but whatever, it's not going to hurt anything. So now we can look at the scene manager, which is going to have the bulk of the code in our example project here. I'm going to walk you through all of it. Obviously, it's not as scary as it sounds. We're just going to break it down piece by piece. So if we go all the way back to the start of the game where we called load new scene, we're calling load new scene. We're passing in the path to our first level, and we're saying we want to use our wipe transition. So I'm going to actually control click on this to take me to the definition, and I'll walk you through this. So the first thing we're going to do is store this transition in a property so that we can reference it later when everything is loaded to make all of our other transitions work. So we're going to need this down the line after our content is loaded. This is where we initialize our loading screen and add it to the scene tree, and then, like I said, start that transition. And then we're going to call our load content function, which is fairly simple. It takes the content path we've been working with. It checks whether we're using the loading screen. It'll be not null if we've added it to the scene tree because we're storing it in this variable. So if we are using the loading screen, we want to wait here until that animation is played in and obscured the whole screen. If we're not, which in the case of the Zelda transition, we're not using the loading screen, which is a personal preference. If we're loading massive levels, you probably do want to display some sort of loading graphic, but if you think back to the old school Zelda games, the dungeons didn't show any loading, they just kind of smoothly transition from one to the next, so I chose not to use the loading screen. We're still doing all the background loading and waiting for that to complete before we start our transition. The difference is we're not actually using the loading screen to display any of that loading progress or handle a visual transition for us. We're going to store the content path here that we passed in because we're going to need that to check in on our loading progress. And then we're going to start the loading process through this ResourceLoader load threaded request. And then, of course, like we've been doing, we have a little check here that will dump out if we pass in something that doesn't exist. And we're going to emit this content invalid signal. So I'm going to skip down to the bottom here for a second. These are the functions that get called when any one of our 4 signals fire off. If the scene manager was a choose your own adventure book, these are the 4 destinations we can end up once we've started loading a piece of content. So up here, if what we tried to load doesn't exist, we're going to emit our content invalid signal. That's going to dump us out in here. It's going to end that function because we're returning, and then it's going to print out this error so that we can debug it. Similarly, if something does exist but it fails to load, we'll dump out here and get a similar error. And then these other 2 are for when we succeed. So if we finish loading and we'll get to that in a second. So jumping back up here, once we've passed this check and we know that our content does exist, we're going to create a new timer to check in on our load progress every 1/10 of a second, defined here by this wait time. So we connect it to this monitor load status every 1/10 of a second. We'll run through this function. And this is just adding it to the tree. You need to add it to the tree in order for it to work, and then you need to start it. So every 1/10 of a second, what we're going to do is we're going to ping the resource loader with that content path that we saved, and it's going to give us back a load status, which is going to come as this array. Because we're loading a threaded request, we might be loading separately multiple things, and they would all come as a different element in the array. We're only ever going to work with one. So every 1/10 of a second, we're going to request a load status from our resource loader, and it's going to give us back one of these 4 status messages. A 0 indicates an invalid resource, in which case we're going to, again, emit that content invalid signal, and then we're going to stop our progress timer to kill this loop. If we get a 1, that's a good signal. That means we're still loading, and it's going to give us back the progress. So load progress 0, because it's the first element in the array, because we're only loading one array. We don't have to track anything beyond that. We're going to get something like 0.1, which means 10% loaded. Anyway, if I go over to my loading screen, in the case of that 0.1, we're going to multiply it by 100, which is going to give us a value of 10, and it's going to give us a 10% load. So in the case of something that loads properly, it's going to continually drop into this section here and update our progress bar until ultimately it gives us a 3, which is our thread has finished loading. And in that case, we're going to get rid of the timer, and then we're going to check back to that transition we saved up at the top. And if it's the Zelda, we're going to drop into our content finished loading for Zelda. And if it's anything else, we're going to drop into this other one. So let's take a look at this content finished loading. This is the method that we're going to drop into. I'm sorry, I keep using method and function interchangeably, and for all intensive purposes, they're the same thing. If I say method, just think function. So if we've dropped into this function, first thing we're going to do is store a reference to our current scene in this outgoing scene, because that's the scene that we're going to discard when we're finished the transition. So when we go from the start screen into level 1, when that's all done, we want to discard the start screen, which is the reference is saved in the outgoing scene. Then we're going to check to see if we're working with the level. So this content, if we come back up here, when we emit this signal, what the resource loader gives us back is, I suppose it's a packed scene, more or less, because we can, I'm calling the instantiate function on it, which means that when we emit this signal, we actually receive the content that we've loaded inside of this content variable. At that point, we can now run checks against this content. So right here, we're saying if the current scene is of data type level, meaning this is a transition from say level 1 to level 2, then we know that the current scene has a data packet for us. So we're going to get that data packet by calling getTree.currentScene.data. So that's this right here, this data variable. And we're going to store it in this incoming data variable because we're going to need that later to pass into the new scene. And then we're going to do a similar check against that content like I was talking about. So at this point, if we're transitioning from, say, level 1 back to the main menu, this will work and we'll grab a reference to that. But then we're going to get down here, we're going to notice that content is start screen, which is not of data type level, and then we're going to skip over this and it's never going to happen. And that's important because if it tries to access the data property on the start screen, it's not going to find it, it's going to crash. So if we've gotten this far, that means our screen is obscured by the first half of the transition. We've harvested whatever data it might have for the upcoming level. We can get rid of our outgoing scene. We don't need it anymore. So right here, we're going to add our new scene to the tree, and we're going to set it as the current scene so that the next time we do this, Godot knows that this is our current scene. And if we try to retrieve the data from this new scene next time, it'll be stored as the current scene. And then down here is where we finish our transition. So added the new scene. We're going to tell our loading screen to finish the transition. So if we've paid fade to black, now we're going to play fade from black. If we're working with a level, we're going to want to place the player in the proper location. Then we're going to wait again, like we did before. We're going to wait for the animation player to finish the fade from black. And then again, if we're working with a level, we want to call that enter level function and kick things off. That's the process that takes you all the way from initializing a scene load through the transition, passing the data off, finishing the transition, discarding the stuff we don't need for our standard transition, which for right now is just the fade to and from black and the white transition. If, on the other hand, we've selected the Zelda transition, which again is this guy, no, not that guy, this one. So kind of smoothly fading up and down, left and right, so on and so forth. We're actually going to do that differently. Again, we're, getting the data to pass back and forth like we did. And then instead of using the loading screen for the transition, I'm just tweening one level in and the old level out, basically. And we can use the information stored in our incoming data on the direction that we're moving to determine the positions that we want to start in and move each level to by multiplying by our vectors and the size of our level or the size of our game screen, which I've just hard coded up here. In a larger project, you probably have these constants in a different auto load. In the interest of simplicity, I just put them at the top of this file. So this basically sets the new level just off screen and moves both the old and new level such that the new level is now centered on the screen and the old one is pushed off. We're then waiting for that tween to finish and doing our initialization and cleaning up our old scene, and then again setting the new scene as our current scene. You could do this with tweening cameras around instead of moving the levels themselves around. Either works. I'm sure there are trade-offs to both. I spent many, many years working as a Flash developer where there were no camera systems, at least not by default. And so I just got used to doing things this way. I do have other projects where I'm using the built-in camera system. To be perfectly honest with you, this is the first thing that came to mind and it works. So you could certainly do it either way. So let's go over to the loading screen before we wrap up and just add one animation together. Let's take a look at this real quick. So we have this transition where we're going down into this dark basement and it fades to black, and on the way up it fades to black. Well, what if we wanted to fade to and from white so that when we go downstairs, it's fading to black because it's dark, and white coming up because we're coming up into the light? How would that work? So we can click our animation player. I like to go to our reset node just to make sure that we're working with the more or less the idle state of the scene. We click on animation, new, and we're going to say fade to white, and that's going to give us a new animation. So let's select our panel, come over here into visibility and we'll set the self-modulate to white. And we're going to pull our opacity all the way down to 0, and then we're going to keyframe that. It's going to ask about a reset track. You can hit create, and then we're going to bump this forward to 0.3 seconds like the other one. We're going to set this to white, and we're going to keyframe that again. So now we have our fade to white animation. We're going to set this to 0.5, so we don't need it to run that long. We're going to add our track on our loading screen, move it one more 0.4, just past when the fading completes, and we're going to report our midpoint. And that's all we need to do for fade to white. Now we need to create our fade from white, remembering we have to swap to for from. Set this to 0.5 as well. And we can keyframe this because that's already where we want it to be. Move it to 0.3. And now we're fading from white, so we're going to go to transparent. We'll keyframe that. And that's all we need to do. We don't need any method calls because this one will run to the end and it will fire off. Where is our scene manager? We're waiting for this. We're waiting for the animation player.animation finish. So it's going to do this fade out, and when it hits 0.5, it's going to emit this signal, and we're going to continue through our code. So now that we've added our to and from, we can go over to our door, and we can just add, let's add right here, another fade to white. And then let's go into our basement scene, select this door, and instead of fade to black, let's select fade to white. So now, if I enter this, we still have our fade to black, but if I go back up, we get our fade to white animation. That's pretty much all there is to it. Okay, so there was one last thing I wanted to show you, which is the loading bar. So I've come in here and I've toggled off where we hide it so that it shows immediately, which will also demonstrate why we hide it, because it's going to make the transitions look a little goofy because they're so fast. This can be kind of hard to demonstrate locally because everything loads so quickly, but what I've done is I've added 5 very large JPEGs to the background. Now, when I go downstairs, you'll see we actually do get our loading progress, and then it completes. And of course, on the way back up, it looks awkward because we don't need it. If we come back into our loading screen and turn this back on, we may not actually see the loading bar depending on how quickly it happens, which is fine because it actually doesn't take that long to load. You see that transition didn't feel like it was hanging. It was a little long compared to the others, but not so long that you would dump out of the game. If it took significantly longer than that, you would want the loading bar to show up. So that demonstrates the loading bar and why we time it out. Okay, now to the actual outro. We did it. I hope you found this helpful, and if you did, please consider a like, subscribe, or share to help me reach more developers just like you. And if you're looking for more coding content, you should check out my Let's Make Snakes series. It's a great way to build your first game in Godot. Until next time, be kind to yourself, be kind to others.